Welcome to my channel. I'm Zhang Xu. Let's work on the problem 44 in chapter 2 together. First thing, we can draw a picture, see what happens. And as we see, there is unmarked police car, so we call it police. It's P, okay. Travels at a constant velocity. So at the initial so the car at the initial it travels constant velocity, initial 95 km/h, converted to meter per second in the international system unit, 26.4 meter per second, and then by a speeder. So then it's S, okay. Travels at 135 km/h. So at the initial, at this point, the speeder, the velocity, initial velocity is 135 km. We can convert it to 37.5 meter per second. Then it tells us just 1 second later, after the speeder passes. So 1 second later, the speeder comes there because this velocity is larger than this one, right? The police is there. And then we see the police officer just steps on the accelerator. So the police just get the acceleration 2 meter per second, and then ask you how much time passes before the police can overtake the speeder. Assume moving at a constant speed. So this one tells us the speeder moves at a constant speed. This one 37.5 meter per second all the time. And the police at the first second, it moves at a constant velocity 26.4 meter per second. Then at the 1 second later, it gets acceleration 2 meter per second square, and finally they reach together, right? They just comes to the same displacement. Now we can see for this problem, for this speeder and police, the displacement in this period, they are moved as same from the initial state to the final state. They are same. Agree? Yes. So now we can write the displacement. The speeder moves with constant velocity v s naught. The time is t1 plus t2. Agree? t1 plus t2. t1 is given. And then the velocity the police moves in two parts. The first part is the t1. This part is the first second. It moves at constant velocity 26.4 meter per second. And then this is the second part. This police moves at a constant acceleration. So at there, this is a initial velocity. The acceleration begins, right? So at the acceleration begins, the velocity is Vp naught times t2 plus 1/2 a t2 squared, and we know the xs equal to xp. And then we input the number inside. We can solve the t2 very easily by solving this equation, and we find t2 is 12 seconds. It's really easy to understand. If we draw a picture and list all the known quantities and figure out what happens in first, second, and the later times. And also we can draw a VT graph, see what happens. We can see this blue line is a speeder. This orange line is the police. So the speeder moves at a constant velocity. Agree? And the police at the first second, it moves at a constant velocity, but it's slower. Then he follows this speeder. He just accelerates. And then at some point, 12 seconds, they just reaches to the same displacement. We can see in this case, we can consider we draw a line at there. So the areas under the line for this blue line should equal to the area under this orange line. Do you agree? So we can see this is just a compensate this part with this part. It's easy. Thank you.